We are working on 10.4 and we are going to work on adding and subtracting radicals. Basically, if they are like terms, you want to combine them. So let's jump right to the problems. This is 3 square roots of 5 plus 7 square roots of 5. They both have a square root of 5, which means you can combine them. I have 3 plus 7, which gives you 10 square roots of 5. You do nothing with the square root of 5. This is like saying 3x plus 7x. You now have 10x. So they are like terms, so you can combine them. Now this one has 2 square roots of 11 minus the square root of 11, which gives you the square root of 11 plus 3 square roots of 44. So I just moved from left to right when you're adding or subtracting. Now I cannot add these together because they are not like terms. If you can reduce them though, you must reduce them. I noticed that the square root of 44 can be reduced. So the square root of 4 times the square root of 11 gives you the square root of 44. The square root of 4 is 2, and the square root of 11 you can't do anything with. So I have the square root of 11 plus 3 times 2 square roots of 11. That 2 square roots of 11 is really the square root of 44. Now, whatever's on the outside of the radicals, you've got to multiply them together. So 3 times 2 is 6 square roots of 11. Now, you have 1 square root of 11, and you're adding it to 6 square roots of 11. You have 7 square roots of 11. Okay, that's one problem. Now for this one, add or subtract to simplify each radical expression. So before you can actually add these together, and they're letting you know that y is greater than 0 or equal to 0 because you don't want any imaginary numbers. So what I'm going to do is I'm going to break these down together first. Before I do anything, 5 square roots of 12y. Well, 5 square roots of 4 times 3 times y. All of this gives you 12y. The reason why I broke it down that way is because I know that the square root of 4 is 2. So I'm going to take a 2 out. Now I cannot square root 3 and I cannot square root y. So those stay under the radical. Now 5 times 2 is 10, and then you're left with 3y. So this is 10 square roots of 3y. Plus, now I'm going to do 6 square roots of 75y. So I'm going to simplify this one. So I have 6 times the square root of 25 times 3y. Now, 25 times 3 is 75, but I can square root 25. So I get 6 times the square root of 25 is 5. Now, you cannot square root 3 and you cannot square root y, so that's going to stay under the radical. Now, what's outside the radical, you've got to multiply together. So 6 times 5 is 30 square roots of 3y. All right? So this is going to be 30 square roots of 3y. Now, if you notice, they both have 3 y's under the radical, so they are like terms. So I have 10 of those plus 30 of those. I now have 40 square roots of 3y. And that's it, just combining like terms. Now, this next part over here, I have 9 square roots of 5 minus 4 square roots of 10. You guys, I cannot combine those. Those are 2 different terms. You cannot combine them. That's it. You can't do nothing with those ones. So let's move on. The next one, add or subtract to simplify the radical expression. First of all, I have a negative, let me just write it over here, a negative 2 to the 4th, or in the 4th root of 32. So I have negative 2, the 4th root of 16 times 2. Now, the 4th root of 16 is 2. So the 2 comes out. But I cannot take the fourth root of the 2 that's underneath there. Now, negative 2 times 2 is a negative 4. And I'm left with 4 square roots of, the fourth root of 2. So the first part is 4 times the fourth root of 2. Okay, so remember 16 times 2 is 32. And I can take the fourth root of 16, it's 2. Now the next one, I have a negative 7, fourth root of 162. Now on this one here, I really don't know what the fourth root of 162 is, so I'm just going to do a factor tree, because that one I don't know. I know 4 can, no it can't. Let's see. Let's just try 2. Let's try 2. So 2 goes into that 81 times. This is going to be 9 and 9. Those are 3s, and those are 3s. So 1, 2, 3, 4, and 5. So a negative 7 times the fourth root of 3 to the fourth times 2. So 3 to the fourth times 2. So on this one, I didn't know of a perfect square root times something that gave me 162. So I used a factor tree to help me get all my little factors. So I end up with negative 7. Now the fourth root of 3 to the fourth is 3. So the 3 comes out. Now the fourth root of 2 stays under. Negative 7 times 3 is a negative 21. 4 times fourth root of 2. So that's going to be a negative 21 fourth root of 2. Now, if you notice, they both have a fourth root. So we have a negative 4 times the fourth root of 2 plus a negative 21 times the fourth root of 2. So the fourth root of 2 is my like term part. Negative 4 plus a negative 21 is a negative 25. And so that's what that one would be. And let's move to the next one. The next one, I have to simplify it first before I can combine them together. So the very first one, I'm going to do this. I'm going to try to make these all be to the third power. So I'm going to get p to the third times p. That is really p to the fourth. Then I'm going to get q to the second raised to the third power, because that is really q to the sixth. Q to the sixth times q is q to the seventh. So this is just my way of I'm messing around with powers, and I'm using all the properties. So the cube root of, now I'm going to go ahead and do this. I'm going to have a cube root there. Some's going to come out, some's going to stay under. The cube root of p cubed is p. I can't take the cube root of just plain old p, so that stays under. The cube root of q squared to the third power, whatever's to the third power comes out, so that's going to be q squared. And then I can't take the cube root of q, so that stays under. Now the next one, negative p q squared, the cube root of 64, and I know that's going to be 4 to the third power, pq. So when I take the cube root of 4 to the third, that means the 4 comes out. So I have a negative 4 pq squared, and I cannot cube root pq. So I'm going to write that down over here. Now, both of these have a cube root of pq, which means they are like terms. I have 1 pq squared plus a negative 4 pq squared. So that means I have a negative 3 pq squared, and then the cube root of pq. And that's it for that one. All right, next one. We have a few more to go. Okay. Next one, add or subtract to simplify. Remember, we cannot add them together right now. We have to simplify them. So I get 6 cube root of, now I need to make these all cubes. So I know 2 to the third power is 8 times another 2 gives me 16. I know that z to the second power raised to the third power is z to the sixth. Z to the sixth times z is z to the seventh. So that one's all broken down. So what's going to happen is some things are going to stay under the radical and some things are going to come out. And don't forget you have a 6 out here. So the cube root of 2 cubed, that means the 2 comes out. The cube root of 2, that 2 stays under. Now, the cube root of z squared cubed, that means that the z squared comes out. Now, the cube root of z, that stays under. So 6 times 2 is 12, z squared, the cube root of 2z. So you cannot break this down any further. Now the next one, I know it's going to be plus 4 square root of, I'm going to go, and these are square roots on this one. This is going to be 10 squared times 2, and then z squared raised to the second, which gives you z to the fourth, times z. And then z to the fourth times z to the first gives you z to the fifth. Because remember, when you multiply powers, you add the exponents. So some things are going to be on the outside and some things are going to stay on the inside. So the square root of 10 squared, the 10 comes out. Square root of 2, you can't do that, so that stays under. The square root of z squared squared, whatever's being squared, comes out. The square root of z, that stays under. So you're left with 4 times 10 is 40, z squared, and then the square root of 2z. Now, they both have different radicals, so you cannot combine them. That's your answer. Okay? We could try to put them all under the same radical, so each radical expression. Assume that all variables represent the positive real numbers. Could try to work on it. However, we don't have to. I think I'm reading more into it than I need to, but could make it all have the same radical, but we're not going to. We're going to go to the next problem so that we can get this done. All right, perform the indicated operations. Assume that all variables represent positive real numbers. Once again, this is going to be 2 square roots of 32 over the square root of 36. Break it up if you can. So I'm going to have 2. I can't do the square root of 32, but I also know that the square root of 36 is 6. Now, I'm going to break down the square root of 32. That is going to be the square root of 16 times the square root of 2. The square root of 16 is 4, and the square root of 2 you can't do. So you're going to have 2 times 4 square roots of 2 all over 6. Okay? I'm going to put that over 1 for a second. I'm running out of room, so I'm going to just rewrite it over here. 2 times 8 is 8. I'm sorry, 2 times 4 is 8. Square roots of 2 all over 6. If you can simplify it, please simplify it. It just makes life easier. I know they both share a 2. So that's going to be a 4, and that's going to be a 3. So 2, the square root of 2, so 4 square roots of 2, that's a 4, remember? I divided by 2, so that's a 4, all over 3. So that's the first fraction. I just ran out of room, so I'm just going to do it over here. Now the next one is this, plus 2. I know that the top one is the square root of 9 times the square root of 3. That gives you 27. On the bottom, I don't know about 108, so I'm just going to make a factor tree on the 108 real fast. 2, that is 54. This is 9 and 6, so that's 3 and 3, and that is 2 and 3. So it's going to be 2 squared times 3 to the third. So on this one, the square root of 108 is going to be 2 squared times 3 squared times 3, which means the 2 comes out, the 3 comes out, and the square root of 3 stays under. 2 times 3 is 6 square roots of 3. Okay? So I get 6 square roots of 3. Now, on the top part here, let me just keep working down. That's going to give you 3. So 2 times 3 times the square root of 3 over 6 square roots of 3. Plus, I'm just going to work my way down. 2 times 3 is 6 square roots of 3 over 6 square roots of 3. Well, that turns out to be 1. So plus 1. You can find a common denominator if you want to. I believe they want us to keep going on this one. So it's going to be 4 square roots of 2 over 3 plus 3 over 3. So that ends up giving you 4 square roots of 2 plus 3 all over 3. And that would be your answer. That would be it. Just double checking it. And 36 times 3. I just got to check something real fast. 36 times 3. Yeah, that's what it'd be. All right. So this is my very last one. So quickly, once again, I have the square root of, let's do 16 times 5 over the square root of y squared raised to the second power plus the square root of 81 over the square root of y to the 5th raised to the second power. These are square roots, so I need them to the second power. So the first one, the square root of 16, I know is 4. I can't square root 5. Over the square root of y squared squared is just y squared, plus the square root of 81 is 9, and the square root of y to the 5th squared is going to be y to the 5th. Now, I believe they want us to actually add those two fractions together, and we can if we have a common denominator. Common denominator would be 4 square roots of 5 over y squared plus 9 over y to the 5th. The common denominator would be y to the 10th. Could we go smaller? No, y to the 10th. Actually, we can do y to the 5th. You know why? Because watch what we can do. I can times this by 1, times this by 1, so that's 9. If I multiply this by y to the 3rd, I get y to the 5th. Whatever I do here, I must do to the numerator. So I'm going to get 4 y to the 3rd square roots of 5. Now, they both have a common denominator. So I get y to the 5th over, and I can't combine the numerators. I can just write them next to each other. And that's it. So if you wanted to get technical and write it smaller, there you go. And thank you. Please read your notes one more time.